Hi, welcome to Lesson 2F, Rational Functions. The goal of today's lesson is to investigate rational functions and their properties and characteristics. The set of rational numbers is the set Q where there is a quotient between A and B, where both A and B are members of the integer number system, and B cannot equal 0. Because if B equals 0, then we get an undefined function. A rational function has the form y equals ax plus b over cx plus d, where c cannot equal 0. The simplest form of a rational function is f of x equals 1 over x, which is called a reciprocal function. The reciprocal of what, you may ask? The reciprocal of the function y equals x. Let's take a look at the graph of y equals x. Here is the graph of y equals x right here. We're going to be taking a look at the graph of y equals 1 over x. What I'd like you to do is pause the video, please, and take a few moments to fill out this table that you see on your worksheet. Fill out these values, plot the points, and then form smooth curve that goes through all those points to see what the graph of y equals 1 over x looks like. And then please come back and take a look at the results to compare with what I do here. Okay, so what I did here is I've got x equals 1/10, so 1 over x gives me 10. When x equals a half, 1 over x equals 2. When x equals 1, y equals 1. And when x equals 10, y equals 1 over 10. Now I'm going to do one more. I'm going to squeeze one more in here when x equals 2. And then that is when y equals a half. Okay, so I'll plot those points. So if I were to plot those points, see if I can change. Yeah, maybe we can do this. So this is going to be a little tricky. 1/10, well, this is 1 right here. X equals 1, so 1/10 is going to be 1/10 of the distance. Oops, not there. We'll get rid of that. So we need to plot about 1/10 and 10. So it's going to be around there. It's going to be really tricky to plot that. When x equals a half, y equals 2. So x equals a half, y is 2. Around there. X equals 1, y is 1. It's going to be around there-ish. X equals 2, y is a half. Right about there. And then x equals 10, y is 1/10. It's going to be around there. Okay, so now I'm going to go on to the bottom part, the negative section. So when x equals negative 1/10, y equals negative 10. When x equals negative a half, y is negative 2. When x equals negative 1, y is negative 1. And when x is negative 10, y is negative 1 over 10. And again, I'm going to sneak in here when x is negative 2, y would be then negative 1 over 2. So I will now plot those points. And so when x is negative 1/10, again, very difficult to plot. Y is negative 10. There-ish. When x equals negative a half, y is negative 2. When x equals negative 1, y equals negative 1. When x equals negative 2, y equals negative a half. And when x equals 10, negative 10, y equals negative 1 over 10. Okay, so now I'm going to draw as nice I can. It's going to be pretty tricky, of course. I'll try to draw nice smooth curves through here. So we'll see how this works out. So this is going to be as smooth as possible. It's not supposed to wave like that. Of course, the arrowhead meaning that it goes on forever, and then we curve down here. Not exactly like that, but pretty close. And I'll do now the upper portion here. Now that is not, sorry, I'm going to erase some of that because that's not exactly where, where it should go. I started out well, I think, but then it went all awry. So I went right towards the y-axis, which I should not do. So I should just kind of go like that, and then here close to the x-axis. Whoops. Yeah, that's not really working out all that well, but it's supposed to be a nice smooth curve, gradually getting closer and closer to the x-axis, which I did not show very well here. But I believe there are examples of this in your textbook, perhaps around, oh, I don't know, page 70. So that's basically what the reciprocal function looks like. Notice that the value of the function approaches 0 as x gets large. So as x gets really, really large, the function is approaching 0. So when we talk about the function, we're talking about y values. In this case, a horizontal dotted line we could draw along here, which would indicate that the graph is approaching x equals 0. Sorry, y equals 0. And that line is referred to as the horizontal asymptote. Sorry about my writing. And the function is not defined when x equals 0, because when x equals 0, that means that we would be dividing by 0, which we cannot do, so that's when the function would be undefined. So the graph seems to be getting closer and closer to the y-axis as x becomes very, very small. So as x gets really, really small, we see that the graph is going closer and closer to the y-axis, but never actually touching it. And same thing when x gets bigger but negative, so it's like the value is getting smaller but is negative, then the y gets closer and closer to, or the function gets closer and closer to the y-axis. And that characteristic is known as the vertical asymptote. Now the one thing about vertical and horizontal asymptotes is that they're actually not part of the graph itself. These are just lines that the graph approaches but never touches. These are the lines that form the shape of the graph, but they're not actually part of the graph. The graph of 1 over x is made up of these two arms here. Okay? Now, if we were to take a look at the summary on page 70 of the textbook,